Okay, so this is going to be the main purpose of today's lesson, as well as why we've been learning all this square root stuff. So what we're going to be looking at is just a couple of basic facts to kind of start with. The first big fact that we need to know is, hey, if a square and a square root cancel each other out. A square root is written using the radical symbol, which is shown on the second sentence. The third one is something that's kind of new. Every positive real number has both a positive square root and a negative square root. So I'm highlighting that because that's a really, really important fact. Now, when I look at the next line, it says, for instance, square root of 9 is equal to 3. Okay, so that's good. That's what we all know. But this is also saying that it's equal to negative 3. What that is going, and why is that? Well, first, we need to kind of look at its notation. The notation would be written as plus or minus 3. It would have a plus sign and a minus sign directly below it. And what that's kind of saying is, hey, it's both positive 3 and it's negative 3. And since we're solving for x, we have to account for all possible solutions that we could come across. So why does it have a negative square root? Well, we know square root of 9. We know 9 breaks down to 3 and 3. Well, so that's going to be the square root of 3 squared, which is just 3 because the square and the square root cancel each other out. However, what happens if I chose to make it negative 3 and negative 3? Negative 3 multiplied by another negative 3 does give a positive 9. And when I go to write my square root, I can write it as the square root of negative 3 squared. And the square and the square root still end up canceling each other out, which leaves us with just a negative 3. So we're going to be using that big fact today to just solve some basic equations that have some x squareds in them. Okay, so when we take a look at some of these problems, our whole primary focus is to solve for the value of x. What value could x be that would make this a true statement? So when we look at problem number 1, we have x squared subtract 16. So the first thing that we would do to this problem is we would want to get rid of the minus 16. We know to cancel out minus 16 with plus 16, and so we do plus 16 on both sides. This minus 16 plus 16 will get rid of each other, and on the right side we have 0 plus 16 would be just 16. Now, we still need to get x by itself, so we have to get rid of the square. To get rid of the square, we need to take a square root, and so we square root both sides. When we square root both sides, that leaves us with x is equal to 4. However, based on the fact that we just said, we'd have to account for both positive and negative 4. And due to that, we would actually write our answer as x is equal to plus or minus 4. Now, when we go to the second problem, we've got 2x squared minus 16 is equal to 0. This problem is going to be the same first step as the last one. We add 16 to both sides to cancel out the minus 16. It leaves us 2x squared is equal to 16. The next thing we'd want to do is now we would get rid of the 2 because we want the equation to basically look like it did on the left side. So we divide both sides by 2, and that'll leave us with x squared is equal to 8. Now, same kind of step as what we did on number 1. We want to get x by itself, so we need to cancel out the square. To cancel out the square, we need to take a square root. Now, this is where all the material that we've learned in the last 2 weeks is going to come into play. We've got the square root of 8. So what we have to do with the square root of 8 is we need to do a little bit of side work. With our side work, what we need to do is we're going to reduce it. So 8 reduces to 4 and 2, 4 reduces to 2 and 2, and so that's going to tell us our reduced radical would be 2 square root of 2. So we're going to plug that back in the equation and replace the square root of 8 with that. And so that's going to give us x is equal to 2 square root of 2. However, do not forget your plus and minus. Okay. Now, that's going to end up being the only even problem that I end up working out today. The rest are all going to be up to you. So on number 3, we have 5x squared minus 23 is equal to 0. Same situation as number 2. We're going to follow the same steps in the same process in the same order. So we're going to start by adding 23 to both sides. to cancel out minus 23. When we do that, that leaves us 5x squared is equal to 23. Now we need to divide both sides by 5, which leaves us with x squared is equal to 23 divided by 5. Now to get rid of the square, we take the square root on both sides, and I want you to look at how I actually square rooted the right side. Since 23 did not divide by 5, I left it as a fraction. And then I had to square root both the top and the bottom of the fraction. Now, there's a problem. That square root of 23 over 5 looks an awful lot like the problem that I showed in the last video in the warm-up. This is a case where we've got a square root at the bottom, it doesn't divide, so that means we have to do some side work to rationalize it. So we've got the square root of 23 divided by square root of 5. Like we said, if it didn't reduce, we needed to multiply the top and the bottom by the denominator, or the bottom. So we multiply top and bottom by square root of 5. That's going to give us the square root of 115 on the top and the square root of 25 on the bottom. Okay, 115, hey, that's not going to reduce. It only reduces to 23 and 5, and both of those numbers are prime. Square root of 25, however, is 5, so we're going to substitute that back in. It's going to tell us the fraction actually reduces to square root of 115 divided by 5. So we're going to replace that 23 over 5 with the 115 over 5. And we cannot forget the plus and minus. And that's going to end up being our answer on number 3. Okay, so now we're going to look at number 5. Number 5, we've got 25x squared minus 7 is equal to 0. So same deal, we're going to start by adding 7 to both sides. That's going to leave us 25x squared is equal to 7. Next thing we need to do is divide by the 25. When we do that, that's going to leave us 7 over 25 on the right side, and the 25s will cancel on the left. So we've got x squared is equal to 7 over 25. To get rid of the square, we're going to square root both sides. So that's going to end up, now square root of 7, we know that doesn't reduce. 7 is prime. But the square root of 25 is just a plain 5. So do we need to rationalize this one like number 3? Actually, no. Because there's no radical in the denominator, there's no need to rationalize this problem. And so our answer would be x is equal to plus and minus the square root of 7 divided by 5. Okay, so on the back, the problems do take up a little bit more room just for the sheer fact that we've got a set of parentheses. However, when we're doing these problems, we're going to be following the same procedure that we did on the front. We're going to cancel the terms out in the same order that we were doing on the front. So on number 7, the first thing that I need to do is plus 5 on both sides to cancel out minus 5. Leaves us 2 parentheses x minus 3 squared is equal to 5. Now just like on the front, we need to divide by the leading term, the 2 parentheses x minus 3. So we're going to divide by 2, which will leave us with the parentheses x minus 3 squared is equal to 5 divided by 2. Now, the next thing I need to do is I need to square root to get rid of the square. So just like on the front, we square root the top and the bottom. So that'll leave us with x minus 3. Now it's just plain x minus 3. The square root, or the parentheses, are gone when we get rid of everything on the outside of them. Is equal to square root of 5 divided by square root of 2. However, there's a square root at the bottom of our fraction, which is not good. So we need to do a little bit of side work. So this is another case where we have to rationalize. So this case, we're going to multiply top and bottom by square root of 2 over 2. When we do that, that's going to leave us with square root of 10 divided by the square root of 4. 10, that only reduces to 2 and 5. 4 reduces to 2. So we've got the square root of 10 divided by 2. So that leaves, going back to our problem, we've got x subtract 3 is equal to plus or minus square root of 10 divided by 2 when we plug it back in. Now to get x by itself, to finish the problem off, we need to get rid of minus 3. So to get rid of minus 3, we're going to do plus 3 on both sides. So that's going to leave us x is equal to 3 plus or minus the square root of 10 divided by 2. Now, since 3 doesn't have any square roots with it, we cannot say that we've got any sort of like terms. That's why they have to remain separate. Now going on to number 9, we've got 3 parentheses x minus 2 squared minus 16 is equal to 0. So the first thing we need to do is plus 16 on both sides. That'll leave us 3x minus 2 squared is equal to 16. Just like on number 7, we're going to divide by 3 here. When we do that, that leaves us x minus 2 squared is equal to 16 divided by 3. Now we need to get rid of our square root, or square by taking a square root. So when we do this one, we've got this x minus 2 is equal to 4. Okay, so my computer just glitched there. And so we've got 4, the square root of 16 is 4, but the square root of 3 is just the square root of 3. So again, we need to take that to the center and do a little bit of side work. 4 over square root of 3. Again, we're doing the side work because we see a square root at the bottom of the fraction. So we're going to multiply this one by square root of 3 over 3. Now when we do that, the top is going to look kind of like a reduced square root, 4 square root of 3. The bottom, though, we've got square root of 3 times square root of 3 would be the square root of 9. The square root of 9 being just a plain old 3. So we're going to take that, we're going to substitute it back in. We're going to substitute it back into the equation. So we have x minus 2 is equal to 4 square root of 3 divided by 3. And don't forget the plus and minus. So now we need to get x by itself. So to get rid of minus 2, we need to do plus 2 on both sides. Again, it's not going to be like terms. And so we're just going to say x is equal to 2 plus or minus whatever 4 square root of 3 divided by 3 is. So before I go on to the next question, I want to just kind of answer something because I know somebody is asking this right now. Why don't we distribute? Well, the answer for this is very simple, and it goes back to something you learned a long time ago, the order of operations. With the order of operations, we know it's parentheses first, then the exponents, multiply, divide, add, and subtract. On this problem, we would have to complete the exponent step of the square before we could multiply by the 4. The 4 has to come after the squaring. And because of that, we don't want to really deal with that. Okay, this is going to, if we actually go through the process of the exponent and then multiply, we're going to generate an equation that cannot be factored. And it's going to make your head hurt really bad. So we're just going to leave that alone. Now what we're going to do is we're going to go back, we're going to look at the final problem. For the last problem on number 11, we're given 4 parentheses x plus 7 squared plus 25 is equal to 0. So the first thing we need to do is we need to move the same spot first as every other problem. We're going to subtract 25 to cancel out plus 25 this time. That's going to give us 4x plus 7 squared is equal to negative 25. Now, just like the other problems, we want to divide by that leading term of the 4. So we're going to divide both sides by 4. When we do that, that's going to leave us x plus 7 squared is equal to negative 25 divided by 4. Because 25 does not divide by 4 evenly. So we need to square root both sides to get rid of the square. And that leaves us x plus 7. And we know the square root of 4 is 2. However, square root of negative 25, we learned something last week that should help us here. We know that a negative needs to become a letter I, which is going to leave us I times the square root of 25. Square root of 25 is 5. So that's going to tell us the answer to negative 25 is 5i. That's what's going to go at the top of our fraction. So we have x plus 7 is equal to 5i divided by 2. And again, we still have our plus or minus. To get x by itself, we're going to minus 7 on both sides. X is equal to negative 7 plus or minus 5i divided by 2. And that's going to be our final answer. Now, in regards to our summary, I've got a basic equation that's just got some variables in it. And so this is going to replace the summary that's already on the note sheet. If we were given this equation, a parentheses x minus c squared plus d is equal to 0, what would be the order of how we have to eliminate things? So the first thing we'd want to eliminate is whatever d happens to be. If it's positive, we would subtract it. If it was negative, we would want to plus to cancel it out. The second thing we'd want to cancel out is the a term, and we would divide both sides by a, unless it happened to be a fraction, in which case we'd multiply. And then we see we've always canceled out the square term next. Okay, and we cancel out the square term by square rooting both sides. Okay, make sure you simplify any square roots, and don't forget your plus and minus. The final thing that we would have to get rid of is the c value that's actually inside the parentheses with the x. And so we're going to move that to the other side the same way that we moved the d value earlier. And again, please don't forget the plus and minus. Okay, so what you need to do is you need to complete the remaining even examples, and you need to submit them to Google Classroom. Whatever you have done at the end of class must be turned into Google Classroom. The second thing, you need to see Mr. Love to get a copy of the test review. Now, 1 through 8 on the front side is working problems like this. That is counting for 1 grade all on its own. The second and third pages are only about reducing square roots and complex numbers. That's going to that was 26 questions. That's going to count as a second grade. The answer key is with Mr. Love. You are free to bring your paper up to the desk to take a look at it. However, you are not to take a picture of it for any reason. Okay, if I find anybody has taken a picture of it, there will be an alternative assignment for the entire class that's going to be significantly longer, so please do not do that. Anyways, I hope you have a good day. If you have any questions, there is a thread open on Google Classroom, and you can just leave me a message there, and I should get back to it in 5 to 10 minutes. I hope you have a wonderful weekend, and I will see you all next week on Wednesday. Please make sure you study for your test.